Good day, everyone. Today we are looking at another interesting science subject, physics, and the topic is dimension of the physical quantities. Definition: dimension of physical quantity is defined as the power to which the fundamental quantities are raised to express the physical quantity. That is the basic definition of dimension. So here to begin with, we are going to consider length, which can be written as length can be written as capital letter L, and mass can be written as capital letter M, and then time can be written as capital letter T. So this length, mass, time is expected to be enclosed in a square bracket like this. Now, this length, mass, time, with respect to this expression, form the basis of other dimension or dimension generally of physical quantity. So we are going to look at examples of dimension of physical quantity with the help of length, mass, time. Examples of dimension of physical quantity, and we are going to begin with the length as well. Now, in writing the dimension of physical quantity, we'll make use of L, capital letter L, capital letter M, capital letter T. All other physical quantity are expressed in terms of L, M, T. So the dimension of length now, let's begin with length as number one, is equal to, I said every physical quantity is expressed in terms of L, M, T. So we have L, M, T enclosed in a bracket. So in this regard, we are considering the dimension of length. So it means that dimension of length is present, while that of mass and time are absent. So you indicate power of 1 here because it's present, while here you indicate 0, 0 because they are absent. So this is the dimension of length. Now, next is dimension of mass, which is also expressed in terms of capital letter M, L, M, T enclosed in a bracket. Now, as it is now, the dimension of mass is present, while that of length and time are absent. So indicate capital letter, power of 1, and here power of 0, 0. Power of 0 means absent. Power of 1 here means present. Now, 3, which is the next, is time, which can be expressed as in terms of L, M, T. So now we are considering dimension of time. So it means that length is absent, mass is absent, but time is present. Next, let's consider area. Area, as you all know, is length times breadth. But here, breadth will be expressed in terms of length. And if breadth is expressed in terms of length, then it means that we have the dimension of length, length in terms of breadth. Let's make it this way: length times breadth. Length is expressed in meter, meter, and then breadth is expressed in meter also, because we said breadth will be expressed in terms of length. So it means that meter times meter is square meter. So the dimension of area will now be written as, in terms of LMT now, LMT. So L now is to the power of 0. Okay. Okay, this unit rather, sorry. This will be L times L, which is L square. L square. So this will be to the power of 2. This is absent 0, absent 0. Example 5, volume. Volume can be expressed in terms of length times breadth times height. And breadth and height can be expressed in terms of length. So we have length times length times length. and length times length is cubic length. So dimension of volume can be expressed in terms of LMT in square bracket. Now here M is 0, you put power of 0 there, T is 0, and then L is present, so you put the power of 3 here. So this is the dimension of volume now. So the next is example 6. We are looking at density. Density is expressed as mass upon volume, and mass is expressed in terms of capital letter M upon volume, which of course is seen in example 5 as cubic length, and the dimension can be written as you can see this can further be expressed as M times L to the power of minus 3. That means that L here is raised to the power of minus 3, while M is raised to the power of 1, and then T is absent. Now the next we shall consider is example 7. In example 7 is velocity. Velocity, which can be expressed as distance upon time. And of course, distance is expressed in terms of length, and time is expressed in terms of capital letter T. So, and it can be written as L times T to the power of minus 1. So the dimension of velocity is written as L m T. So L is present, you write 1. M is absent, T is minus 1. That's the dimension of velocity. Example 8, we have acceleration, which can be expressed as velocity upon time. And this velocity can also be further be broken down as distance upon time, upon this time again, which is also written as this distance now is expressed in terms of L upon, when you apply the mathematics, you have time, this time times 1 over t. That will give you L upon t times t is t squared, or L times t raised to minus 2. So the dimension of acceleration can be written as LMT. That is what is present here. L is present, 1, power of 1. T is present, minus 2, power of minus 2. Then M is absent. So that is dimension of acceleration. Example 9, force can be expressed in terms of mass times acceleration. And mass times acceleration can further be broken down to velocity over time, equal to mass times velocity can also be broken down to distance over time. By the time you apply the mathematics, you have distance over time squared. So this mass can be written in terms of capital letter M times distance in terms of length, which is capital letter L over T squared. So the dimension of force now can be written in terms of LMT in square bracket. Now this can further be broken down as M times L times T to the power of minus 2. So here L is raised to the power of 1. Then mass, which is capital letter M, is raised to the power of 1. Then T is raised to the power of minus 2. So this is the dimension of force. Now, the next example we shall consider is example 10. That is pressure. Pressure is expressed in terms of force upon area. What is force? This force can further be broken down as mass times acceleration upon area. And this can also be broken down as mass times acceleration is velocity over time. And this area can also be broken down as length times length. So we have mass, that is capital letter M here, times velocity. Okay, let's still go further. Mass times velocity is still broken down as distance upon time square, with this now, over length times length, which is equals to mass can be written in terms of capital letter M times distance in terms of L upon T square upon again L square, which is ml over T square times 1 over L square. So you have this can get rid of this. So you have m L to the power of minus 1, T to the power of minus 2. So the dimension of pressure now can be written as, okay, this place is too, the dimension of pressure can be written in terms of L m T. So here m is raised to the power of 1, L is raised to the power of minus 1, and T is raised to the power of minus 2. So that is the dimension for pressure. L to the power of minus 1, m to the power of 1, and T to the power of minus 2. So the next example we shall consider is force. That example what? 11. Example 10 or 11? 11. That is, we are considering impulse. And impulse is explained in terms of force times time. Force times what? Time. And this force can be broken down as mass times what? Acceleration times what? Time. Times time. And we have mass times acceleration is both broken down as velocity upon time times time. This time can get rid of this, true force. So we have mass times velocity. And we have mass times velocity is further broken down as distance over time. So we can finally write that mass is written in terms of capital letter M times distance in terms of L upon time in terms of T. So the dimension for impulse is, or let's express this as m L times T to the power of minus 1, so that it will be easier for us. So I have L m T. L is raised to the power of 1. M is raised to the power of what? 1. T is raised to the power of minus 1. So first, the dimension of the following. 1 determine the dimension for work. 2. You determine the dimension for kinetic energy. 3. Let me give you the formula for the sake of this. Work is force times displacement. Then kinetic energy is half mv squared. Then the next one is potential energy. mgh. Fourth, we have momentum. Is mass times velocity. Then fifth, we have power. Work upon time. So the next, I want to keep you busy. 6, we have frequency, which is 1 over time. 7, we have wavelength, which is length. Then 8, we have stress, which is expressed in terms of force upon area. 9, we have strain, which is expressed in terms of change in length over original length. So with this, I want to encourage you to please go over the video again and see if you can attempt this dimension of these physical quantities. And that is why I gave you the formula in order to serve as a guide. In our next video, we are going to assess these exercises. Thank you for watching this video and following me throughout this video. Please do well to share and subscribe this video. Thank you. Till we meet next time.